This is our group's project for Mech 3380. Our project is a screwdriver optimization, and my name is Nick Bueller, and with me is
Adrian Montes,
Zach Till,
and Win.
So we want to begin by describing what the problem is. And the problem is when people use a flathead screwdriver to pry two objects apart, it can snap with little force. This is a huge issue because now you have a sharp metal piece flying in the air, and this can injure the user or people standing around. Our goal is to optimize a flathead screwdriver that can be used as a pry tool and as a screwdriver, but this would be a safer alternative to current ones. So we have details and boundary conditions. The material we chose is steel, with Young's modulus being 200 times 10 to the 9th GPa, Paishan's ratio at 0.3. Our load will be 50 pounds applied to the edges of the flathead, and our boundary condition is encased to the round blunt handle, and these will be described more in the next image.
So this is the model screwdriver that we created in Creo, and the two variables that we're going to be changing are the length and the thickness of the steel rod. We were able to apply the applied load of 50 pounds to the tip of the screwdriver, and we placed the boundary conditions at the end of the handle where the user would be holding the screwdriver. Here is a chart of our various designs with their corresponding variables and volume and maximum stress values. Our original design has a length of 5.5 inches and a thickness of 1/4 inch. And then in our second design, we decreased the length to 3.5 inches. And then for our third design, we increased the thickness to 0.375 inches. And then lastly, we ran a test with both the decreased length and the increased thickness. These are our Fourier equations. The first two equations correspond to the volume with the change length and then the change diameter, while the last two equations correspond to the maximum stress with the change length and change diameter. And here we use those values as well as the variables from our original design to create these equations for the volume and stress to be used for the optimized values.
what is shown on the left is the displacement for the screwdriver at its original state. We can see that the displacement is at its highest towards the flathead part of the screwdriver, and the max displacement value was 7.563 times 10 to the negative 5 meters. Looking at the right, we can see the stress of the screwdriver, where the highest stress is shown at the top to be 1.781 times 10 to the 5 Pascal. For the optimized length, we went ahead and changed the length from 5.5 inches to 3.5 inches. And when looking at the stress, we can notice that it has decreased to 1.174 times 10 to the 5th Pascal. And we can also see that the displacement has also changed to 2.027 times 10 to the 5th meters. Optimizing the thickness, we can see that it is even has increased the stress even more, and now it's shown as 8.286 times 10 to the 5th pascals, and we can see that optimizing the thickness and also previously discussing the length has made the screwdriver stronger to use as a prying tool. Now, as we take a look from both optimizing length and thickness, we can see that this will be the optimal solution to use as a prying tool. We have the new stress, which became to be the lowest at 7.121 times 10 to the 4th Pascal. And also the displacement was great at a value of 4.66 times 10 to the negative 6 meters. So going through each part of the abacus analysis, we can see that choosing to optimize both the length and thickness will greatly improve the tool, and this can be used to pry the tool objects without breaking apart.
And this is our MATLAB code that was given to us, and we modified it based on our values in the Fourier equations based on the stress and volume equations. And as you can see, we set upper and lower limits based on somewhat realistic values of our designs that are capable. And from that, we got an optimal length of 2 inches and an optimal thickness of 0.343 inches compared to our original values, which were 5.5 inches and 1/4 of an inch of a thickness. And as you can see, the optimized screwdriver has a lower length and a lower diameter.
And finally, to conclude, we'll do a quick review. So the original length was 5.5 inches, and our new length change is 3.5. Our old diameter was 1/4, and our new diameter is 3/8. And then our original volume is 3.24 inches cubed. It should be inches to the third. And then our new volume is 3.34 inches cubed and then continuing, our original displacement was 7.63 times 10 to the negative 5th inches. And our new max displacement is 4.66 times 10 to the negative 6 inches. This new design creates less change in displacement, which is also what we're looking for. And then our new max stress is 7.12 times 10 to the 4th pascals compared to the original 0.78 times 10 to the 5th pascals. And like the previous, this new design creates a lower stress, which is better for our new optimized design. And to conclude, a decrease in length and an increase in diameter of our screwdriver will end up creating a better tool and a safer tool for the user and bystanders.